Okay, so today I'm going to be presenting pretty much on behalf of one of our end users, SABIC, the Saudi Arabian fertilizer company. I'm Rob Zucker. I am the software manager for OWL Computing Technologies in Ridgefield, Connecticut. And let me see. Okay, so the Saudi Arabian fertilizer company, Safeco, they're a large producer of, as you can see, some of the chemicals down below, some of the very volatile chemicals. As you can see, that security in their process is very important. A hacker with any knowledge of their inner workings could do a lot of damage and cause a lot of destruction. So I'm going to talk about a case study of how they were attacked and how they contacted us for a solution and the solution we provided them. So there's some interesting quotes. Cyber attacks on the industry's infrastructure projected to result in damages costing nearly $2 billion by 2018. And isolation works. So our products are based on network isolation. We'll get into that. Okay, so after the attack, their initial defense was to just unplug. And that caused a lot of impediments to their efficient operations of their business. Okay, so the challenge is, I'm going to start from the bottom work up. I think it's more logical. So first, limit unauthorized access to the plant network from outside of the plant. Ensure network security operations within network domain separations, and then to restore the business continuity by allowing data flows to resume. And what we did was we installed a hardware-enforced data diode to enforce one-way data flows where appropriate, and we'll show you that. And then the cybersecurity defense needed to maintain the plant and business networks separate for security purposes, the separation between the two, and to replicate their data to both networks. So this was the original setup prior to the attack. Some OPC DA servers, some alarms and event servers, using DCOM to a Yokogawa historian with a software firewall. And then on the business network, here's the network domain separation. On the business side, you had Yokogawa historian clients. So immediately following the attack, they pulled the plug on the software firewall, disconnecting the plant operations from the business network. And thus, the business side of things didn't have the data necessary for efficient control of the plant network. So what a data diode is it's a one-way data communication device. Our specific data diodes are hardware enforced, meaning software, eventually someone can find ways around your software. A hardware enforced solution, there's technically no way to get data in the opposite direction. Okay, so here's the installation as it was after we came. So you still have your OPC DA servers in the plant network. Okay, right here is the so this here is an OWL server that basically it's an OWL OPC server, and basically, this is a server that sits in front of, this is our hardware data diode. So this is collecting data both via DCOM and some tunneling applications that we have that will tunnel the DCOM through our proprietary TCP tunneler. Okay, and then so this here is the network separation point, where now we're on the business side of things. Again, this is a one-way data transfer. Here's another OWL OPC server, in which case the information is then distributed back out to OPC servers residing on both of these flanking servers with the historians replicated on the business network. So now you have access via OPC to any one of the servers that were on the plant network. And like I said, physical separation and one-wayness prevents anyone from getting back into the plant network for any destructive purposes. And there's a little more detail about our AL-OPC server and how it distributes with the connectors here that convert back into DCOM after the tunneling operation and then back down into the historians. So essentially what we were able to do is we were able to enforce no access into the plant network from outside the plant network. We are actually able to separate the business network from the plant network in a way that is hardware enforced to ensure that no communications can get backwards. And we restored their business continuity and actually added a little additional functionality in that they were able to connect. They were able to connect to their OPC servers on the business network in a totally replicated fashion. So here are a couple of key points about what the business needs that were required that we were able to safeguard. Security breach called for urgent need to secure the plant and business operations. Cybersecurity risks and challenges were effectively solved. Business continuity and data flows were reestablished. And a scalable architecture deployed that replicates to other sites easily. Very modular design. And provides a new level of cybersecurity and risk mitigation previously unavailable. So, any questions? Hi.